Hi all, welcome to Acharya Coding School. So in this class we can discuss about the kernel and the modules. So in the previous classes we have discussed about the shell script and how to do the loops, everything and functions, everything we have discussed in detail. So in this class we can discuss about the Linux kernel. So the Linux kernel is the part of the Linux operating system. So it's mainly acts as a bridge between the hardware and the software. So we already discussed about the previous classes about the Linux kernel, and it mainly manages the communication between the hardware and the software. So it's mainly acts as a bridge between the hardware and the software. So here the software applications makes the system calls. So the kernel here translates between the hardware instructions. So we have a CPU scheduling. So we are deciding which process will be running. So there will be like memory management. So it's mainly allocates and deallocates the RAM. And we have like a device management. So it mainly interacts with the hardware via drivers. So mainly here kernel versus operating system. So here the kernel is equal to core engine managing the resources. So whereas operating system is equal to kernel plus user space. So user space we have like a tools like shell, libraries, graphical user interface. So we have like a different types of operating system tools. And we have like a different types of kernels. So monolithic and modular and hybrid as well. So we can discuss each one in detail. So here monolithic kernel Linux means everything runs in a kernel space. So it's mainly having the fast. So it's mainly runs inside the Linux only. So we have like a microkernel. So it's mainly used for minimal kernel we are using. So present if you are taking more services run in the user space. So it's compared to more secure and slower as well. So here we are using the Minix like kind of operating system. We are using the microkernel and we have a hybrid kernel as well. So it's mainly combination of both monolithic and microkernel. So it's mainly like for example if we take the Windows and Mac operating system. So whatever the operating system you based upon the hybrid kernel we can use. So it's mainly Linux supports monolithic kernel mainly, but supports dynamic modules as well. So we can add and remove functionality without any rebooting our system. So we have like a kernel modules. Kernel modules is nothing but the plugins for the kernel. So you don't need to reboot or restart anything. So here mainly the kernel module is a piece of code. So we are mainly using for the loading purpose and unloading purpose. So depends upon the at any runtime. So we have like a different types of kernel modules. We have like a networking drivers. So networking drivers are nothing but Ethernet or Wi-Fi. So in your home we have the Wi-Fi, right? Same as like we have the network drivers. And we have the file system drivers. So it's mainly like NFS, extension 4. So we have like a different types of drivers as well. And we have a device drivers. So it's mainly USB, sound cards and disk controllers. We have like a different types of device drivers as well. So what are the main benefits of these modules? Because it mainly provides the flexibility, and we are using in the faster development as well, and we are using for easy maintenance we are using the modules. It mainly saves our system resources. So we are loading when only we are needing our system. So what is a modules? So here the modules extends the kernel functionality without recompiling. We have the different types of device drivers. So if you take kernel is as the brain. So we can take the device drivers as the translators. So a device driver is mainly a special type of kernel module. So that's mainly allows the operating system to communicate with the hardware. It mainly enables the communication between the operating system and the hardware device. So if you think of a translator, so it translator, what will he do? So he provides the translator. Same as like here, it translates between the operating system and the hardware device. So why we need of upgrading the kernel? Because we have the security patches. So it's mainly useful for fixing the vulnerabilities, and it's mainly helpful for us in the bug fixing and performance improvements. So when you fixing any bugs, if you are getting, then it mainly improves our system stability, and we are using for supporting the new hardware. So it mainly enables the new drivers. So we have like a new features as well. So by using this, we are getting the better performance. Till now, we have discussed about the Linux kernel, modules, types of the kernels. So we have discussed till now, and about the device drivers. And we can discuss about the troubleshooting as well. Troubleshooting the kernel logs. So here the kernel logs looks like a black box of a aeroplane. So for example, if we have in the take the example of aeroplane. So they have the mainly it mainly helps us. They will record everything happen inside our kernel. So we have the D message. So mainly stands for the diagnostic message. It helps kernel ring buffer logs. It's mainly containing the boot messages, hardware initialization, driver loading, errors and warnings. So we have like a different types of features available in the D message. So it's mainly displays kernel ring buffer logs, messages generated by the kernel. So especially during the boot and the hardware events. So we have like a different types of available in the D message. So it's why we are using, because it's mainly useful for debugging the driver and device as well, and hardware issues as well. So if you are getting any such type of issues, with the help of D message, you can able to easily debug. So let us execute each and every command in practical. Let us connect to our instance. So start a new instance. Yeah, we have started our Linux machine. Now we can connect to our Linux machine. So before going to this, so we can deal with the basic Linux kernel commands. So we can check which kernel version we are using in our Linux machine by giving the command uname -r. So present we are using the 6.1.153.175.280 version. We are using the Linux kernel version. And we have ls mode. So it's mainly useful for list of loading the kernel modules. So we are like a different types of kernel modules. So it's mainly displays the list of kernel modules. So we have a command for mod info. Sudo mod info. Let us try. So sing mod. So we have like a any kind of mod information. So that's why we haven't created any modules, right? Let us try in this one. Mod info, and we need to give the command as well. Let us execute in this way and try once again. So we need to give the mod info. After that, we need to provide the module name. So if you see here, we are getting the details of our mod information. So it's mainly to view details of our modules. And we have a to load a module. We have a command for modprobe. Modprobe. After that, we need to command, for example, a loop. So it's mainly loading the module. So you can verify ls mod. So we have created the loop module. It mainly helps in the loading. If you want to remove the any module, you can use the command called rmmod and you can give. So for example, if you can delete button, you can give rmmod button. So we have given rmmod button. So now verify once again whether we have deleted the module or not. So now here, if you see in the modules, so the button is not displayed. So we have deleted the module. And we can use the D message as well. So D message is using for viewing the kernel messages. So if you print like that, the error itself we are getting more. But from the D message, I want to identify the error itself. Only error log I want to identify. For that, what we need to do? So we are using the filter. So for filtering purpose, which command we are using? Grep, right? So we need to provide the grep. So we haven't, in this we don't have any errors. So that's why we haven't got any. So in this we have any error, we can get error message. So we have the command for churn method. -k. So which we are using for the viewing the kernel logs. So we can able to identify if we are getting any errors in the kernel logs. So it's mainly useful for if any device is not detected, if you have any issues in the deep driver failures and boot time issues. So for those we are identifying and use. So it's mainly accessible by a German player on system ID systems. Thank you.